I want to welcome everyone today to our virtual seminar on looking at the role of water activity and coffee quality. So we're going to have two presenters today. It'll be myself presenting from Decagon, and I'm just going to give an overview of looking at the coffee industry and then the role that water activity plays in that industry in terms of both roasted and green coffee. And then our second presenter, which will be the bulk of today's seminar, is Ian Frethheim from Cafe Imports, and he's going to be talking about basically the research that they have done looking at the link between water activity and green coffee quality over the last few years. So this is data that they've collected kind of in coordination with us, helping provide instrumentation. So if we look at the coffee industry, the coffee industry is a $60 billion industry and is the second largest commodity in the world in terms of trade value. So with an industry of this size, understanding factors that contribute to quality has a significant monetary value. So the coffee industry can be broken into two key segments, the first being commercial or commodity coffee, sometimes referred to as bulk coffee, and then also specialty coffee. So these two industries have a very different approach to quality and how carefully they're going to monitor that quality. So in commodity coffee, the main emphasis is going to be safety and preventing fungal growth in the green coffee form. And then in roasted coffee, the primary goal is going to be maximizing the shelf life, so the stability of the roasted coffee. In the specialty coffee market, which is makes up 51% of the U.S. market as of last year, there's going to be much more emphasis on quality in each individual cup. So this market demands superior quality and a lot more finesse in the entire process. So everything from harvesting the coffee, processing it, to basically the roasting, and then into the cup that we drink. So within the life of coffee, there are going to be two distinct phases that I'll touch on. Basically, these are going to be very different from a quality standpoint. So there's going to be green coffee and then roasted coffee. So when discussing storage and shelf life and stability of these two, they're treated very different and have significantly different physical attributes which play into that. So when looking at the role of water in coffee quality, basically that's going to also play into storage. So we're going to discuss both green and roasted forms. One of the key things to monitor is water. So water mobility and availability play an important role in the roasting and storage of coffee. The reason for that, coffee beans are a very hygroscopic matrix and can readily take up moisture when exposed to it in the environment. And so that can happen during processing of the beans, during drying of those, as well as storage in either form. So if we break this down and look at green coffee, in green coffee, water is going to be monitored during the processing of that, also the drying of the beans, as well as during storage of the bulk green beans. So that can be in the warehouse, as well as transport of those beans to their final home. When roasting coffee, water becomes important in the roasting process itself, as well as storage of the roasted coffee and the type of packaging material that might be needed for optimal stability. So throughout the life of coffee, water is an important element that should be monitored. So in terms of analyzing and understanding the role of water, it's critical when dealing with coffee quality. We've established that. The question is, how do we monitor the water and what measurements are optimal? So in dealing with moisture analysis, there are going to be two key measurements that are utilized. One is moisture content and the other is water activity. So when we look at moisture content, we're essentially dealing with a quantitative amount of water in a sample, and that can be reported on either a wet or dry basis. So there are a number of different methods available for determining moisture content, basically the percentage of water in your sample. Depending on the industry you look at, you'll use a variety of different methods. One thing to keep in mind, this is an extensive property, so it does depend on the amount of material that you're using when you generate that result. That's going to give you how much water you have in a given product, or how much water you would have in your green or roasted coffee. The second measurement is water activity. So water activity is a measure of the energy status of water in a system. So this is a qualitative measurement as opposed to a quantitative measurement. This is an intensive property that does not depend on the amount of material, so it's basically a bulk property. And this measurement is going to give us more of an idea of how the water is behaving in the system, as opposed to simply how much water is there. So let's dive into the water activity portion of this a little bit more. So in terms of water activity, I have two definitions up here. One is the current working definition, and that states that water activity is a measure of the energy status of water in a system. Okay, so people are probably wondering, what is the energy status of water? What does that really mean? The old definition actually helps to kind of visualize what's going on. The reason we've moved away from this is some of these terms mean different things to different people. But the idea here is that water activity is the amount of free or available water in a product as opposed to bound water. So basically with water activity, we're looking at the energy of water as compared to how pure water would behave. So in a sense, using kind of the old definition approach, this is the degree of water that's being bound to the cellular surfaces or chemicals in the product. And it's kind of a measure of how tightly that water is held physically within that matrix. So in terms of measuring water activity, if we go back to thermodynamics, this is actually a ratio of fugacity, or the escaping tendency of water in a substance. We can replace that by looking at partial pressures. So when we measure water activity, we're actually looking at a ratio of the vapor pressure of water above our sample at a specific temperature that needs to be controlled. And we're going to divide that by the vapor pressure of pure water at that same temperature. So this is essentially our water activity reading. Water activity is going to be reported as a value between 0 and 1, 1 being the water activity of pure water. An important thing to note is that water activity can also be referred to as the equilibrium relative humidity of a substance. So if we take our water activity value and multiply that by 100, that's the equilibrium relative humidity. Keep in mind this is not to be confused with just simply relative humidity, which could be more something reported in terms of the environment. This is actually going to be the equilibrium relative humidity of the product itself. So with water activity, now we kind of have an understanding of what that measurement is and how we obtain it. The reason that this is important is that increased water activity is going to accelerate things like reaction rates, chemical reactivity, non-enzymatic Browning reactions, different enzymatic reactions, as well as play a significant role in microbial growth. So all of these factors are going to play a role in coffee quality and stability, so water activity becomes a very important measurement. So here's kind of a schematic, basically a very simplified version of what we would do if we're taking a water activity reading. So we have a couple containers here. One's got our product in the bottom, this little blob of food, or this could be some coffee beans. And essentially what we're going to do is we're going to wait until in that sealed system we reach equilibrium. And we're going to hold this at constant temperature and pressure. And so what we're looking for is equilibrium and to establish basically what the vapor pressure is above that sample. And that's going to be related to what we would get if we had pure water sitting in that sealed system. So this is kind of our ratio of the vapor pressure above our sample versus the vapor pressure above pure water. So that's essentially what we're going to do in water activity instrumentation. There are a couple instruments I'm going to talk about that can be utilized to measure water activity. So there are two main options in terms of water activity instrumentation. One is going to be using a chilled mirror dew point methodology, and the other is using an electrical properties-based sensor. So with the chilled mirror dew point, this is a primary method of measuring vapor pressure, meaning it's not calibrated. So we're directly calculating the vapor pressure based on the feedback from our sensors. So it's not a system where we actually monitor another property and relate that back, which would be a calibrated approach. So in terms of water activity measurements, this approach has the highest accuracy. So most standard benchtop units are going to read plus or minus 0.003 water activity. So if you're looking for better control in a lab setting where we control the temperature of the block, this would be your best and most accurate approach to obtaining a water activity measurement. The second methodology is electrical properties based, so you can have capacitive based sensors or resistive based sensors. These are a secondary method, meaning that they do require calibration. So what we're actually reading is a change in electrical properties, and we're going to relate that back to our water activity value. One of the main instruments utilized in the coffee industry in terms of water activity right now is the Pocket. So this is a small portable version. Doesn't require being plugged in, so you don't have to be in a lab setting where you can actually utilize electricity. This can be used out in the field. The accuracy on this unit is plus or minus 0.02, so still decent, but you're definitely not getting that lab grade. Also with this unit, you don't have temperature control, so that kind of has to be factored in with the readings, but it's very simple and easy to use and can be transported easily. So these are a couple options in terms of taking water activity measurements and how you would be able to do that. So I'm going to switch over now from actually looking at just water activity and start talking about some of the ways that water activity is useful. We're going to start out by giving kind of a broad overview of water activity in roasted coffee. So moisture has been the measurement utilized in terms of looking at quality in roasted coffee in terms of water for many, many years. But I'm going to talk primarily just about water activity, and in many ways that's going to be a better indicator of stability factors and quality attributes in roasted coffee. Basically, throughout the life of coffee in terms of the roasted form, water activity is going to be useful from everything from the roasting process itself throughout storage until that product's utilized. So going over some of the work that's been done, there has been some evidence out there that suggests that water activity helps determine the time and temperature requirements during roasting and establishing roasting profiles. So this is primarily work that's been done by different roasters. Finding publications on that is a little bit tricky, but there definitely seems to be evidence to suggest that water activity does play a good role in optimizing that. Also, there's been some work done by Labuza and Cardelli. They did this on roasted ground coffee, and this work was really important because it showed that an increase of about 0.1 water activity resulted in a 60% decrease in shelf life in that roasted coffee form. So the strong effect of water activity on the kinetics of shelf life, basically that deterioration, they primarily thought would be due to non-enzymatic browning reactions taking place. But you can see that there's a definite impact of an increase in water activity and what that does to looking at the shelf life. Some other work done by Nicoli and his group, they looked at the secondary shelf life of ground roasted coffee, that being the life after the consumer opens the bag, so that would be the secondary shelf life aspect. Their research focused on three major factors, so the temperature, oxygen concentration, as well as water activity. And what they found is that higher levels of water activity accelerated oxidation and volatile compound release during the storage of coffee. The oxidation factor is minimized due to normally occurring polyphenols in the roasted coffee form, so that really wasn't the primary thing that decreased the shelf life of coffee and that secondary shelf life effect. However, volatile compound release was very apparent if you were at water activity values greater than 0.25. So what they established is that maintaining roasted coffee below a water activity of 0.25 is optimal for flavor retention. So while that was looking at basically after the bag's been opened by the consumer, it's also an important value for just looking at the storage of roasted coffee across the board. Some other work done by Patia and Sacchetti in 2007 also found that water activity plays an important role in the texture of roasted beans. So that actually has practical applications for the grinding process. So based on the water activity of the roasted coffee beans, that'll play into how you would want to grind that product for optimal flavor retention. So now let's switch over and look at water activity in green coffee. So again, this is going to be separate form, different physical attributes. So some of the things that have been done with green coffee, and this has probably not been as well studied as the roasted coffee form, but there is a little bit of research out there. So one of the first things is looking at determining optimal roasting conditions. So this I actually have on both slides because it's basically the fact that roasted coffee, we're actually establishing roasting profiles, but monitoring the water activity of the green coffee itself also plays into how you're going to roast that coffee. One of the other factors is looking at the release of caffeine and the decaffeination process. So some work done by Swiss Water Decaf they've found that water activity will show how readily the green beans will release that caffeine and also how stable the final product is after you dry those beans back out. One of the other factors, microbial stability within green coffee. So when you talk about microbial stability within green coffee, it's usually in reference to ochratoxin production, and that is going to be directly controlled by water activity. So if you look at all the literature available on water activity, the correlation with microbial growth is very well established. So within this, there are HACCP guidelines out there that state that coffee in cherries, if you're looking at coffee cherries in parchment form or just straight green beans, should not be kept at water activity levels between 0.8 and 0.95 for more than 4 days in order to prevent ochratoxin issues. So as long as you maintain the coffee in any of those forms below that level, and you don't exceed 4 days at that level or higher, then you should be fine in terms of ochratoxin. Also, maintaining the green coffee beans below a 0.69 water activity. So this is going to be, after you've processed the coffee, but throughout the storage and transport of those green coffee beans. As long as you maintain a level below 0.69, that will also prevent fungal issues and subsequently ochratoxin production. If we switch over and look at some of the physical stability aspects, in terms of physical stability, there's been a lot of work done. Rakuli's group has looked at various aspects of physical stability. And what they did is actually determine a monolayer moisture value for green coffee. And they established that value at 0.61 water activity, utilizing moisture sorption isotherms. So this monolayer moisture value is associated with where a product is in its most stable form, and the optimal moisture and or water activity to keep the product at or below. So if you move beyond that water activity value, that monolayer water activity of 0.61, then the product becomes more unstable. And as Ian will mention later, this actually plays very well into what the specialty coffee industry has seen in terms of a water activity value that you want to be below. Some other work by Patia established a critical water activity range. So this is kind of a range of critical water activities that you'd want to be, around or below. And that was based on the ability of coffee to undergo phase transition from an amorphous to a glassy state. So the range they established was 0.538 up to 0.760. So a pretty broad range. But basically beyond this range, water acts as a plasticizer and starts impacting textural properties as well as increasing the rate of many different reactions. So if you move over that critical water activity, the time dependency of hydration becomes very relevant. So this aspect is important in terms of practical applications, especially during the storage of green coffee at different humidity conditions. So making sure that you're maintaining levels definitely below that 7.6 mark, but there will be more information from Ian about kind of the optimal value to be at. So lastly, there's been recent data, and this is primarily what Ian's going to talk about, basically suggesting that there is a correlation between water activity and green coffee quality, especially over time. So how that quality declines with storage based off of the initial water activity that they saw. So at this time, I'd like to turn things over to Ian to discuss what they found in their research over the past few years related to water activity and green coffee quality over time. So thank you, and now we'll let Ian take over.
So here's a quick overview. We're going to talk a little bit more about specialty and commodity, and specifically one of the key things that differentiates us and one of the key things that got us interested in water activity in the first place. I'll make a few comments on an attribute of green coffee called respiration. I'm going to talk about my perspective of making a presentation on water activity, and then I'm going to launch into some things here called Tim's questions. I gave a presentation in Copenhagen last year, and the organizer, Tim, asked me some questions that really got to the point of what the heck are we interested in this for anyway. So the bulk of my time I'll talk about those, and then I'm going to set aside some substantial time as well to talk about a project that we're doing in Costa Rica with a guy named Carlos Batalla. We'll get into that. That's actually extremely exciting and very interesting. So let me launch ahead and see how far along we can get here, and leave some time for questions as well. So specialty versus commodity. One of the key differences that Wendy alluded to is that in specialty, we're really using a hedonic quantitative and qualitative assessment rather than just a simple yes, no. That is, we're looking at flavor attributes. We're looking at do we like it type of quality questions, not just is it above grade, is it below grade. Let me get my pointer out here for you. Now, so we have identification of defects. Water activity is, as far as I can tell, pretty darn set as far as it's probably pretty useful if you're talking about molds, if you're talking about microbials. As Wendy mentioned, that science is, it's science. You can test it and repeat it and repeat it and repeat it and test it, and you're going to get the same answers. And especially what we're doing, we're looking at this more complex assessment of degradable material, and we're asking, are there water activity indicators for the various degradations that we'll see over time of things like organic acids, of sugars, of soluble material that makes a great cup of coffee. And this little graph here is, I mean, it's pretty generalized, but this is one of the things that really piqued our interest. And what we're looking at is sort of the specialty coffee score range. There's some compression because we only go up to 90, even though we use a 100-point scale. But starting at 80 points and moving up to 90, this line represents something of pricing for us. And you can see that between 80 and 84 points, not a huge difference. And then all of a sudden we have this cliff here from 84 to 86. Now, one of the things that happens is if we purchase a coffee up here, let's say we purchase an 87-point coffee and it loses 2 points, so now it's an 85 on arrival or shortly thereafter, we've fallen off of this cliff, which creates a substantial financial loss for us, and then that impacts backwards and forwards, by which I mean back to origin and forwards to coffee roasters. So this is something that we really want to get around. Figure out how can we stay above this cliff when we start above the cliff, that kind of thing. Now, if I go back one slide really quick, this picture here is actually quite illustrative of one of this very thing. This is actually an extreme example. This is a pre-ship from April 22nd last year that we scored at 88. We had a pretty good high water activity number for us, 0.6374. That's a high number for us. And this is where it's a little more interesting. Moisture is 12.2%. So the common going number for specialty coffee and moisture content is 12%. If you're above that, you got to start looking at it. If you're below that, you're good to go. 12.2 and 88 points, you say, well, that's pretty close, and 88 sure tastes good. So let's go for it. We went for it, and we've got a coffee arriving now, and already by September, we're sub 80. Water activity has spiked. Moisture content has gone up a little bit, and this represents a huge loss and a significant problem if you're a specialty coffee importer. So a whole lot of specialty coffee is nonlinear, which complicates things, but it also makes it pretty interesting. Respiration. As you can see here, green coffee beans retain the vegetative characteristic of respiration. What's interesting about this and important for us in specialty coffee versus commodity coffee is that we are purposefully playing with fire. If we wanted to, we could take our coffee beans and dry the heck out of them, use water activity to say, as long as we stay above this value, the lipids are going to be fine. As long as we're below this value and quite low, we're not going to see any trouble with enzymatic activity. We're not going to see any trouble with really anything. But we're not doing that because the same thing that the coffee bean as a seed, so the coffee bean is a seed, the same things that the coffee bean as seed wants to use, we're talking about starches, carbohydrates, fats, and proteins, are the same things that we want in the coffee bean as bean when we roast and then brew the coffee. And so You see my little picture here. It's a person versus plant sort of battle. It's like a tug of war. And we really are trying to leave the coffee in a alive state, right? Okay, so here we go. Instead of playing with fire, we're playing with the living edge of respiration. Okay, so presenting water activity. One of the things is it can be boring. What I mean by that is the answers don't jump out. We've found out, to my personal disappointment, that it wasn't magical. What we ended up looking for were patterns, and fortunately, we've seen them, and we've seen them slowly grow as we keep dumping data into our spreadsheets. The patterns actually just get slightly stronger day by day by day, which is really exciting. Science on water activity, as Wendy was talking about, that's pretty darn settled. The extent of application is not. So that's what we're doing. We're taking water activity, we're looking at all the theory, we're looking at the science, and we're trying to apply it to a kind of an interesting application, as Wendy said, something with a little bit more finesse. So can water activity predict this very specific hedonic loss? And of course, it's difficult because part of that hedonic value has to do with cupper preference, or what we have here, panel variation. So this is a work in progress for us here at Cafe Imports. We had this question: do we go with sample size, or do we try to create a lab environment and run specific tests? And what we decided was we're going to go for huge sample sizing, because we do a lot of samples. We ran a little over 4,000 samples through our cupping lab last year alone. Already set up for that. All we needed to do was plug in water activity measurements and keep going. So that's what we went for. Now, one of the things that also occurs and is very important for us is that this needs to be a longitudinal study. That means we want to see offer samples, we want to see arrival samples, and we want to see spot cupping samples, spot samples, things that we've stored in our warehouse for a number of months, all of the same coffee, to see what the different values specifically from early in life end up doing later on, so that we can come to use this predictively. So this means, well, this takes time. Longitude takes time. We started back in 2012, very end of 2012, and we've kept going. Currently, in our overall data pool, we've got 8,500 data points. Now, the one that I use for the charts that you're going to see in a little bit is smaller. I've restricted that strictly to samples that we have purchased. This is to say, samples that we've essentially said yes to. So that cuts out all kinds of unsolicited offers. That cuts out everything that was below grade. Basically, what I'm saying is, if we approved a sample that says, at one point we said, for some reason, this is too grade. So whether that is a micro lot and it's an 88-point coffee, or whether that's just an entry-level specialty at 80 points, at one point we said yes, gave it an approval, and so now we're going to track and see what it does over time. So with this study, there are lots of confounding factors and statistical noise. Shipment error, roast variation, potentially moisture content, coffee variety, processing method, panel variation, water activity. That's the one that we want to study, but who knows? It could be any of these other things. And then the final one is, you name it, it could impact the outcome. There are just so many variables, especially using score as our rubber meets the road sort of index. So here we are. We said controls versus sample sizing. There were so many things that needed control. What we decided to do was just go for a huge sample size, see if a pattern could emerge, really in spite of the lack of controls, and then go from there. So here are Tim's questions. What we want to know is, does water activity affect quality, shelf life? Is there an ideal water activity? And how does water activity during drying and storage affect quality prior to shipment? Okay, so first one, does water activity affect the quality of coffee, and how? Here's my answer: is maybe, and in fact, at this point, it's probably. Now, maybe and probably, this is me kind of hedging a little bit I will go ahead and say that we are beginning to use water activity as an index for decisions here. It's a little bit interesting because it's not an industry-wide thing, and so we're not trying to spring it on people and say like, oh, well, now we have this magic number that you missed. But we are using it as we look at what's the likelihood of this coffee lasting. What do we want to do with this coffee? I've already talked about some of these variables, confounding factors. However, as we dig deeper into those, we're going to see that water activity looks like it's actually kind of fundamental to a number of things affecting cup quality. And here's another question. So when we say, does it affect quality and how, there's at least two questions there. So we've talked about coffee, especially coffee in particular, as a live product. And then we're also looking at stable water activity. So we talk about quality. Do you want the most vibrant popping coffee you can imagine right now? Or do you want a really, really good coffee that's going to last over time? These are different types of quality that we're kind of talking about. So high water activity does not necessarily mean poor quality coffee. Our observation is that high water activity, and when I say high water activity, we're really talking about 0.59. Observationally, I'm talking about 0.59 and up. And in fact, that monolayer value is quite interesting because what we have come to is that from 0.59 to 0.61, that's like a little range where we're looking at maybe if that's a really high scoring coffee, maybe that's like a rock star coffee, hard living. Scores really high, gets in, scores really high, and then short life. But above 0.61, we're just not seeing very much, and you can see this here. So we have this system where we flag coffees right at pre-ship or right at offer, and that's always number one in my system here is always an offer. It's always pre-ship. It's always at origin. Number two is always the initial arrival to our warehouse. Number three is always a later warehouse spot cupping. So we're looking at it. This is roughly 7 to 8 months. Now, this H, this purple here, is above 0.61, and you can see just on average across our 3,000 point data set, 4,000 point data set, that high number not only begins lower, but it continues that downward decline and remains lower than all the others. Now, the M3, that's that 0.59 to 0.61, we just came upon that 0.61 number by getting a bunch of data plugged in and then basically moving sliders in the spreadsheet to say, okay, when does coffee really show a decline? When does this M3 line really start to fall off? And above 0.61, it really tanked. However, I could move that slider up to 0.61, and at least on arrival, I was getting relatively good numbers. And in fact, some of the higher scoring coffees, these are averages across a huge pool. Some of the higher scoring coffees in that 0.59 to 0.61 would arrive well. But then what you'll see here is this green line actually dives pretty dramatically over that next 5-month period. So one of the next steps, of course, is going to be to kind of like push number 3, that later spot cupping, closer to number 2. What we want to do is see like, well, okay, how steep is that? Is that a linear thing, or is it like shallow, and then all of a sudden a drop at 6 months, at 7 months? Where does that occur? When we're talking about low water activity, I'm sorry, I'm a little frenetic here, but I'm just moving right up the graph. When we're talking about low water activity, our M1s, we're actually talking about 0.55 and practically down to 0.41. The slider here is at 0.351. There's not really any coffees represented in that. I just kept moving the slider until it didn't work anymore, and 0.351 is the number I got to. So what we're seeing with those coffees, M1 is on average best pre-ship score, best arrival, longest stability in the warehouse. So those are the two questions. So you've got long stability like this, but then there are some in that green line, 0.59 to 0.61, that really are kind of interesting. And I would say that within the context of a transparent business model, there is some potential to bring those in, because those are frequently coffees that are really exciting and really giving interesting flavors. So maybe you bring those in, you say, well, this is a very risky coffee to us to purchase back to origin. And then you say, okay, we've got this coffee. It's amazing. It's not going to last very long, but it's just amazing. You really need to try it. That's, I think, a potential for water activity on some of these what I'm calling M3 coffees. So does not necessarily mean poor quality. It does seem to indicate an increased risk for problems, especially longitudinal, and it increases what we'll call volatility. Now, volatility, again, can be good and it can be bad. You know, it can be exciting and it can be disastrous. So we're looking at both things. And water activity, of course, as we're going to get into later, is internal to the bean, but it's also environmental. We've been talking a little bit about equilibrium. So in theory, you can have perfect equilibrium, a perfect environment tailored to your water activity. Maybe you're going to stretch that out in terms of lifespan. But if you have a slip or a blip anywhere along the line, that's what we're talking about with volatility. You get stuck in port, you get a rainy day, you get something like that. Now, the other thing we want to talk about, are there still lipids to oxidize? Are there still sugars to consume? Are there acids to release? Okay, high water activity, just like in that little respiration thing that we saw. High water activity is not itself going to work to do this. It's going to encourage the oxidization, the consumption, the release of all of these things that we actually want to drink. But it does not mean that these things are not present. Actually, very low water activity, when you get down below that 0.351, that seems to correlate essentially with past crop coffee, what you might call papery or cedary, woody, old tasting, dead coffee, coffees that don't have these things anymore and are not viable as specialty coffees. Okay, so here's another one. Does water activity affect the quality of coffee and how? Well, observationally, now we're talking about correlation, not causation, we've got, on average, our highest scoring coffees in this 0.42 to 0.473 range, and grouped around that up to about 573 if you want to, depending on where you want to take it. Now, this table is interesting also because we've adjusted it for Decaf and Ethiopia, by which I mean I've eliminated those two things from this data. Decaf because the water activity and moisture content on decaf can be just really all over the place. Ethiopia because we tend to purchase from Ethiopia for our own inventory, only high-end things, whereas Colombia, we're buying the full spectrum. For most countries, we're buying the full spectrum. From Ethiopia, it's predominantly high-end stuff. And those also tend to just be lower moisture, lower water activity. So they also tend to raise the scores here in these lower numbers. We want to say, well, what if we get rid of Ethiopia? What's that going to do? Is that going to just destroy everything, or is the pattern going to remain? And in fact, the pattern remains. When I add Ethiopia back into this graph, basically what you see is this bar bumps up a little bit, this bar bumps up a little bit, this bar bumps up a little bit, and that's it. But the general pattern, that general slightly skewed bell curve towards the just sub 5 remains intact. Okay, and again, does it affect coffee quality? Well, now you'll recognize this. This is half of the coffee taster's flavor wheel from the SCAA, and then this is essentially the defective half. And many of these, actually, it occurred to me recently, many of these things relate to water activity as we're talking about how do things function inside and intra and inter the coffee bean. So one of the major categories, fats absorbing tastes, fats absorbing odors. What we're going to see is that water activity is key in terms of allowing things to pass through what would otherwise be barriers. Water that's bound is not a transmitter or medium for movement. Fats and acids changing chemically. Okay, well, water activity is a catalyst. We've talked about already about enzymatic activity, talked about oxidation, there's sugar browning stuff. So now what do we got? We've got 1, 2, 3, 4 things already. Loss of organic material. There's our fifth. And in this case, we've got water activity sort of as a conveyor and as a catalyst. When those numbers get a little higher, you're looking at both just shedding material, and then you're looking at this catalyst mechanism where enzymes and things that you might call internal to the bean are consuming this material. So finally, and this one is this has actually been a conundrum for me for quite a while. Does water activity affect quality? Now, so here's water activity, moisture content, and scores. When we started this, we wanted to say maybe we're going to replace moisture content with water activity. That has not been the case. However, this particular graph, which I keep trying to prove wrong by adjusting data, which I just can't accomplish that. It's been a real thorn in my side. So we'll start here. This blue line, this is just the average of that entire 3,500 approved coffee data set. The average score here is 84.18. Now, these next four bars, when the water activity is between 0.35 and 0.59, and the moisture content is greater than 12, so really there's nothing at 0.35. This is, in this relationship, the water activity is almost always going to be 0.58, 0.59, and this moisture content is always going to be 12.1, 12.2. But when we're in that relationship, the average score here is 85.11, not only the highest, but also significantly higher than the average. Take one more step, and so this is kind of those what I was calling those rock stars. Probably not going to last as long, but really vibrant and interesting right now. Move over one step here. Water activity still in that okay range between 3.5 and 5.9, and now we've bumped the moisture content under 12 more into a range that roughly correlates with the measurements we've seen in green coffee, 7.6 and 12. This again is higher than our average score, 84 and almost 3/4, 84.7. Now, these next two both represent an inversion of that relationship. Now what we're going to say is what happens when water activity is high, above 0.59, and the moisture is in a good range. That's what we're looking at here, and all of a sudden we hit 83.5. Not a horrible score, but a little bit over a full point under the average for everything. And all we've done is reversed this, what is the predominant index that we're looking at. And then again, when both water activity and moisture are high, we've got 83.03. So the question's sort of becoming, okay, so when water activity is in a good range, no matter what moisture does, our scores are slightly to significantly above the average. And again, when water activity is high, regardless of moisture, our coffees are dropping below the average. This is something that suggests or really encourages further research. So shelf life. Does water activity affect shelf life, and how? And again, we're going to say probably. I'm going to keep hedging on you like this. Very early on, when I started presenting data to the bosses around here, one of them looked at me and looked at the graph and said, oh, well, it just looks like coffee gets bad after a year. Now, that's kind of true, but what we're looking at is the rate at which it gets bad. Going back, we saw those M1s, those lower range water activity coffees starting off at 86, and after about 7 or 8 months, we saw 83s, 85s, 84s. Not a great thing, but the rest of that bunch was down closer to 80, and significant numbers of those actually are below 80. So what we're looking at is rate of degradation as longevity. after 8 months, you kind of have that expectation. And until Wendy and those guys at Decagon actually figure out a way to just stop coffee without changing its flavor or anything, I think that's going to be what we're going to see, is that degradation over time regardless. Now, we have viability. We've talked about this a little bit. Viability in terms of a seed, that's a common phrase. Is the seed viable? Yeah, what's the percentage rating? Okay. But it's also related to, is this viable as a specialty coffee, i.e., is it an alive coffee? And so water activity, if it's too low, is going to be detrimental to both of those things. And again, if it's high, it's going to catalyze the functions, the activities of both of those things. So this is where we're kind of playing with a little bit of dangerous or a little bit of risk. Migrating moisture, we've spoken about this, loss of organic material. We've got that in and out of the bean, mirroring or macro to the in and out of cell walls, which water activity is what allows transfer of material in and out of cell walls. And then we've got our enzymes and microbial activity. So what we're going to say is it's very, very likely. And we have this question, volatile or unbalanced water activity rather than just water activity and shelf life. That is, if you're in a humid environment and you're not like in Grain Pro, or you're opening and closing your Grain Pro, you're going to have, or if you're in a hot environment, you're going to have a different equilibrium than if you're in a cool, dry environment. Or here for us in Minnesota, our warehouse is enormous and actually really buffered. If it were not, winter and summer would present very different equilibrium points for green coffee for us. So this is our environmental interaction. We've been looking at water activity as a buffer. Lower water activity, not very low, but low in those lower ranges, it seems like what we get is sort of a buffer for green coffee. We purchased a couple of Colombians from neighboring farms, same lot size, pre-shipped at the same time. I mean, everything was really the same. Variety was the same. Processing was the same. One difference, one had water activity about 0.61. One had water activity pretty low for Colombia. I think it was about 0.54. They shipped together. They got delayed together. They arrived together. And while they were both 88, 89 on the pre-ship side, the high water activity presumably due to that delay in port down in Colombia, really tanked in terms of the score, and the other stayed actually quite stable for us. So low water activity, we're kind of looking at it as a buffer. This idea, you can pave the road with leather, or you can wear shoes. So maybe you could do all reefer containers. Maybe you could just environmentally control everything from like the moment you pull it off the plant to the moment you put it in your roaster, and you don't have to worry about water activity. Or maybe you can figure out best practices for water activity. You know, we already spoke about this thing, like you get 4 days at this level and you need to be below it. That'd be like equivalent to wearing shoes. You can deal with water activity at each phase of the process chain, and you have this buffer. However, volatility is simply a risk factor. It does not mean bad coffee. It just means higher risk, potentially higher payout, potentially really great coffee. A lot of times people will describe really vibrant coffees as really active, really alive, really enzymatic. These are just flavor descriptors coming from people who have no idea about this stuff. But all the descriptions relate back to this base idea of volatility. So what we're talking about then is a cost-benefit analysis. Okay, so here's a little, we saw the M1 and the M3, 4.5 or 3.5 to 5.5, and M3 being that 5.9 to 0.61. This is just score ranges, right, and the count of coffees by score range. So what you can see is that we've got a couple in here up in the 90-92 for those M3s. However, in terms of like that later spot, we've got 0%. 0% of those coffees make it to that 7-8 month mark at that plus 90 score. 14% of these M1s make it that long. Now, that's actually significant. 8 to 9 months, you know, when a crop year is, I suppose, a year, but practically speaking, maybe slightly less, for 14% of these 90-point coffees to make it through, that's kind of an interesting number. Okay, is there an ideal water activity for green coffee and why? Well, we've already spoken about this some. We have yes and we have no. It depends on what you're looking for. If you're looking for that long-term stability, I would say, based on our data, what I'm saying to my bosses is yes. We want to be down in this range, 0.45 to 0.55. And this is actually a decagon chart here where it kind of describes all of the things that happen at different water activity levels. These are things that you can test and get results and test and confirm results. Kind of handy in the coffee world. It doesn't show up like that all that frequently. However, there's some evidence that maybe 0.59 to 0.61 is actually a little bit more ideal if what you're looking for is that truly alive coffee, and you have people who can process and ship with a more volatile material. I've got marked here Ethiopia. You get lots of stuff like people saying delicate, elegant. You get these sorts of descriptions, not necessarily bad or mild or anything like that, but just a different type of description describing this coffee, and these are the ones that tend to last the longest. Colombia, you frequently get all of these more exciting descriptions, vibrant, lively, sparkling, all of these things that are powerful, that kind of stuff, and they tend to be more frequently in this range. They don't tend to last as long. Okay, now we're going to get into some kind of what we're moving forward with and really interesting stuff. How does water activity during drying and storage affect quality prior to shipment? Now, we don't know. And in fact, probably what we're looking at is that it's going to be a relatively complex relationship between water activity, relative humidity, and temperature. We've done a number of trials, some small ones in Huila and Costa Rica, and then this larger one with Mr. Carlos Batalla, also in Costa Rica. That's just this year. We're in the middle of that, and that's actually really, really interesting. So there are various methodological challenges, lot separation maintenance, me over-engineering the first few trials, just the general time commitment of anyone who agrees to do this, and then consistency of measurements. It can be challenging. One of the early observations is that AW, water activity during drying, seems more volatile than the moisture content. So this was essentially the same coffee. This is in Costa Rica, and we ran a little on a patio, and we ran a little through a mech dryer. And the blue line here is water activity. You can see how it's up, down, up, down, up, down, up, down, always tending or trending down. Moisture content, you might plateau for a while, but it's pretty steady both ways. And the mech dryer flattened out the water activity here a little bit, but actually still popping up and down. And on this bump back up, you had like a rainstorm. This was like a rainstorm at night, and it was enough to bring water activity back up. This gap here was a gap in measurement, again, high humidity, and it actually brought the water activity up. We saw that a couple of times. There was a stretch where we couldn't actually get some moisture measurements on some coffees in Colombia due to rain, and the moisture plateaued, water activity shot way up. So much more volatile, a little bit unsure exactly what that means, except that it does seem to be the pattern no matter how you're drying coffee. Now, one of the things that may come out of this is that, incomplete drying. Sometimes people have talked about that in the cupping room. Oh, this wasn't dried properly. This wasn't dried enough, something like that. In a lot of ways, what you're talking about, too high moisture, you're talking about not wanting to purchase water, whereas you have people who are selling you coffee and they want 12%. When we've asked for 10.5%, there can be pushback, because 10.5% across a container can equal actual weight. That equals actual money. So a challenge is to prove that with that lower moisture, and more specifically with a slightly lower water activity, we're going to have a better shot of maintaining that coffee and selling it, and that's going to translate into higher purchase pricing over time. So we might start talking about too high water activity instead of too high moisture, and we're going to start talking about instability and volatility of the coffee contents themselves. So now we'll get right into the real interesting stuff, this trial with Mr. Bataya. Carlos contacted me and had seen the Copenhagen presentation, or had maybe not, maybe had read some of the stuff I wrote for some industry magazines early on in our process, and was very interested and curious. He saw Cup of Excellence was using water activity and wanted to know more about it, but not only wanted to know more, was really proactive and was like, well, why not? Why don't we just see if we can actually do something with this? So he contacted me, explained his interest, and said, I'm set up to do micro lots, and in fact, I'm set up to do day lots. How would you like to do something? And so we kind of had this conversation back and forth. Me saying, well, this is what we've done. These were the challenges. This is what we'd like to do. And him saying, okay, we can do that. We can do that. We can do that. And what we ended up with were 28 farm level day lots. So we're talking about very, very similar coffees. Really, the difference is the day that it's harvested. This is much smaller than a lot of times what you'll have is day lots that'll be combined into micro lots. So we're talking about nano lots. So we've got 28 farm level day lots dried on raised beds in a parabolic dryer. I mean, we're taking a ton of confounding factors, a ton of non-controlled, what should be controls, and actually controlling them just right here. A very near identical origin, and really, from my experience and what I saw, meticulous processing. Everything's very clean. Everything's very organized. Very difficult to achieve this level of variable control, and it was really wonderful because this was already in place down at Carlos's place. So really wonderful to just come in with the water activity trial and basically just plug into a system that was already operating at such high efficiency. So we go in, and I got these relative humidity and temp probes from Wendy as well. And so we're placing these in the coffee and throughout the dryer, and also environmentally. And we're going to kind of watch what's the relative humidity, what's the temperature each day as the coffee's drying. And then we have Carlos there taking water activity measurements through the process. And the idea is, what's it look like? What's water activity look like? Can that become an index for not only coffee quality and us saying, yes, no, maybe so on a pre-ship, or yes, no, maybe so on a arrival coffee, but can it also actually function as a useful tool for coffee processors to do with drying this coffee? How do I want to manipulate the environment to best dry this coffee? Now, the parabolic naturally has slightly hotter and cooler zones. It also has naturally slightly more and less humid zones. So what we end up getting is a relatively tight range, but still a range of temps, humidities, and drying times over this very, very, very uniform group of coffee lots. So what that means is we have very similar coffee, a slight range with specific zones that we get to compare as we keep cupping these coffees. So we have our pre-ships. The pre-ship basically the cup did not correlate with water activity. That's expected. That's what we've seen. High water activity, high cup score, low water activity, low cup score, low water activity, high cup score. No correlation. The first couple times we did these trials, we thought, oh, well, this is just a waste of time. And then actually what we have seen previously is that slowly but surely the water activity starts to tie out with the cup scores. Stuff that started lower stays where it was. Stuff that started higher, if the water activity is low, stays where it was. The high water activity stuff starts to tank. So that's kind of what we're looking for. And what's really interesting about this one is that if that pattern holds true, it's basically saying, well, with the exact same coffee, the water activity has determined the ultimate trajectory of each of these little nanolots. So we're looking for longitudinal differentiation, cup and water activity between these water activity levels. Is there an ideal endpoint for water activity when you're drying coffee? Or probably, and I would say much more likely, is there an ideal water activity arc or profile to aim for through the drying process? And then the question that gets really interesting is, what are the roles of temperature, relative humidity, and water activity? Can we find a new methodology for drying coffee which is to say, okay, water activity at 2 days, at 3 days needs to be looking like this. The relative humidity right now is like this, and so we need to move temperature. Or temperature has been like this. We need to adjust relative humidity. Can we make a more dynamic model for coffee drying to follow a water activity arc that we're able to see produces high scoring and long lasting lots of coffee? All right. A little longer than I hoped to go, but I've had a lot to get in. Let me bump over here, and this is our final slide. I think we have a question and answer now. I'll toss it back to Wendy, but then of course you've got both of our emails here if there are further questions after the time is up here on this Q&A period.